Swayam Prabha. Digital India. Educated India.
Hello everyone. Last class I was discussing about resistance spot welding. So, I stopped my lecture during the time of different types of operating variable in resistance spot welding. Today I will discuss about the rest of the part of resistance spot welding, especially the effect of operating variable, then heat balance, its advantage, disadvantage and its application. And after that I will start different types of other resistance spot welding and its detail. So, we have observed that generally the process parameter used in resistance spot welding are time factor, pressure, electrode tip size and surface condition. Okay. So, I have already discussed about this time factor, then pressure and electrode tip. So, these two parameter also remain, that I will discuss today first. So, first of all I will discuss about electrode tip size. You know that the electrode permit the current to flow into the workpiece, that we already observed. So, it is logical that the size of the electrode tip generally control the size of the resistance spot weld, that we can say. Like you see, you can observe that in case of resistance spot welding, generally two workpiece generally overlap each other. After that a electrode generally used here. Now, depending upon this electrode tip size, actually depending upon this electrode tip size in the sense here, like this is the electrode, it has a tip, that means tip means let us see the circular cross section, then tip cross section will be like this. So, we already observed that if the tip cross sectional area is A, then current density, if the current passing through this electrode is let us I, then this current density is represented as I by A. This is called current density, you can say, density of current. This we can write. So, higher the current density, generally higher will be the chances of heating, correct. Now, that is why what happens, this electrode tip size, this cross sectional area have a significant effect on this nugget size. Nugget size means whatever the weld size it will created or a spot it will created, it generally affect this electrode tip size. This you should keep it in mind, because higher the size of this nugget. That is why you should keep it in mind. Generally the size of the nugget, or you can say size of this spot is little bit smaller than this size of this electrode tip cross sectional area. This you should keep it in mind. That is why here I have written. So, if the electrode tip diameter is too small for the application, then the weld nugget size also will be small. So, this will then our weld joint quality will be weak, correct. Now, if the electrode tip diameter is too large, then there is a danger of overheating the base material. If it is too large, that then also it is not good, because there is a chance of overheating the base material, and due to these things there is a chance of development of voids and gas pocket at the weld location or nugget location. That is why very large or very small types of electrode diameter is not preferable. There is some optimum diameter of electrode is required to use. It depends on thickness of the plate. Like I am showing in next slide, you can observe that this electrode tip diameter you can determine by using the thickness of the plate. Generally higher the thickness of the plate, higher should be the electrode tip diameter. Okay. So, electrode tip diameter, that is why here I am just showing a relationship for low carbon steel. It is applicable for low carbon steel. it is generally equal to this electrode tip diameter should be equal to 0.1 inch plus 2 into thickness of the 2T means T is the thickness of the plate. So, if a plate thickness this T should be in inch, because here I have written this is in inch. So, electrode tip diameter whatever the things here it will come in inch only. Okay, this you should keep it in mind. So, if the thickness of the plate, if the thickness of the plate is 0.1 inch, then what happens, your electrode tip diameter let us D will be your 0.1 plus 2 into 0.1. This you should keep it in mind. Now, if this thickness of the plate is in millimeter, then you have to convert this T in terms of what it is called inch. This you should keep it in mind, because here everything should be in inch. Now, let us we are using two different thickness of plate, for a spot welding joint. Let us one is bigger size, another one is smaller thickness. Then for this case, this is your T1 and this is your T2. Now, for this case here for T1 and T2, two different generally diameter of the electrode will be there. So, you see, so depending upon the thickness of this T2 and T1, here the diameter of the electrode tip size will vary. Now, heat balance, this is a very important phenomena in case of resistance spot welding process, because this heat balance means whatever the joining we are going to make, for that generally this two plates should be equally heated. This you should keep it in mind. But that means in both the plate the fusion zone size, that means the weld zone size should be 50% size type of sharing should be there. What I am telling, understand? So, that means this heat balance means both the plates should be heated in equal way. Okay. So, it may be defined as the condition of welding in which the fusion zone of the pieces to be joined are subjected to equal heat and pressure. This you should keep it in mind. So, heat balance purpose is to heat the two pieces which is subjected to equal heat and pressure. This you should keep it in mind. Now, if the plate thickness for both the plate, this plate and this plate is same, then what happens, this heat balance generally is not required, it is not a problem there. But if there is two different thickness of plate, then what happens, this heat balance there is a problem. This you should keep it in mind. And another problem can be if these two plates which have same thickness but different types of material, then there is also some problem of this heat balance. That is why here I have written already, when the weld has part of unequal thermal characteristics such as let us one plate is copper, another plate is steel, that is it has unequal types of thermal characteristic, correct? Like copper has high thermal conductivity, it has less electrical resistance, but whereas steel has low thermal conductivity and it has high thermal resistance. So, what happens, due to this high thermal resistance, what we observe that this steel will be more localized heating than copper. So, for that case generally what happens, heat balance is an important phenomena. How we can utilize heat balance condition for this dissimilar types of metal, that I will discuss in subsequent slide. Apart from this thing, if the plate thickness is different, there is also some chance of different types of heating condition in two plate. So, there is also required some heat balance precaution. Okay. That things I will discuss in next slide in detail. Like let us two different plate which has which is made of copper, this topper only let us made of copper and below one is made of steel, let us. Okay. Now, we know that as copper has, so what we are discussing, let this is copper and this is our steel. So, as this is copper, so as this copper has very high thermal conductivity, so heat can dissipate easily, as well as its resistance is less, that is why here generally localized types of heating will be less. For that reason, if we use in copper side some smaller types of diameter electrode, then what happens is a smaller types of diameter electrode, then what happens is current density will be high. So, by controlling the increasing this current density, we can increase the intensity of current in the weld zone, and we can we can do the heat balance in these types of copper steel types of joint. As the steel has low thermal conductivity and high electrical resistance, that is why this steel side generally the diameter of the electrode should high, because you see here let the cross tip area is A1, here let the tip area is A2. Now, in case of resistance spot welding, generally the current passing through both the electrode is same, correct. Now, so depending upon this current density, that means I1 I by A1, its generally will be higher than this I by A2, correct, because this is generally lesser cross section, that is why this will be there. So, due to this higher density, generally this heat balance phenomena will be there. That means, by varying the current density in the dissimilar material, what we can do, we can equalize, you can say equalize the fusion characteristic in this two different dissimilar material. Apart from this thing, another things also we can use, where generally this electrode diameter will be remain same, but at the tip of the electrode there will be used some high resistance types of metal. High resistance types of metal, here I have shown here by using this black color one, which is a high resistance types of material. So, by using this high resistance types of material such as tungsten or molybdenum at the contact point, where what we can do, the result is to create approximately the same fusion zone in the copper as well as in steel side. Okay. This also you should keep it in mind. So, what you have to keep it in mind, for generally higher thermal conductivity plate region, there we should use high thermal resistance related material like tungsten and molybdenum for same diameter of electrode. So, this is another way of heat balance technique. Now, here I am going to discuss about the advantage and disadvantage of this resistance spot welding process. So, here you see in advantage, like what happens, it has low initial cost, it has very high productivity, here generally less skilled worker is required, no S preparation is required here, like for other welding process where generally S preparation is required, here no S preparation is required. Here generally it can be automatic or it can be semi automatic types of process. Here its production efficiency is very high, and here there is no noise and harmful gases, like in fusion welding, other arc welding process where there is a chance of harmful gases, some noise and other thing. This types of thing is not available in resistance spot welding process, and it has some disadvantage also. Generally this resistance spot welding generally used for a limited thickness of material because of current requirement. It is generally less proficient for high conductive types of material, what I have already told you, because for high conductive types of material we have to do some precautionary condition, like what happens, we have to do some heat balance types of phenomena over there. That is why what happens, for less for high conductive equipment or high conductive material, it is less proficient. And weld joint generally contain comparatively small tensile and fatigue properties. It also consume high electric power. Now, we will discuss about its application. It is generally widely used in automobile, aircraft industry. It is also used in steel household furniture. It is used in making containers, then refrigerator and other metal stamping assembly. Okay. Now, we will discuss the next part of today's lecture, that is different other categories of resistance welding process, that means type of other categories of resistance welding process. What I have already told you, generally previously I was discussed about resistance spot welding, which has a very wide application. That is why I have shown that thing initially. Now, we will discuss the rest of the resistance welding techniques. So, overall this resistance welding process can be categorized in 6 major type, that is, first one is resistance spot welding, which I have already discussed in detail previous lecture, and second one is called resistance seam welding. This resistance seam welding have some variant, like what happens, it can be operated by using high frequency AC current, as well as it can be operated by induction types of heating. Okay. So, that is why this resistance seam welding, which is represented in RSEW, which can have 2 categories. One is called RSEW HF, that means high frequency, and another one is RSEWI, that is called resistance seam welding induction assisted. Okay. Now, third category is called projection welding, fourth category is called flash welding, fifth is called offset welding. This offset welding also have 2 different variant. It can apply high frequency AC, as well as it can apply induction assisted types of heating system. Okay. That is why this offset welding also have 2 variant that I am showing here, and sixth category is called percussion welding. Now, here one thing you should keep it in mind, this all the welding process generally utilize either single phase or 3 phase AC using step down transformer or rectifiers. This you should keep it in mind. That means, here use single phase or 3 phase AC using step down transformer. What I am telling, understand? Now, resistance spot welding can capable of joining refractory metal and its alloy, lot of different types of refractory material and its alloy. This also is a important characteristics of this resistance welding process. Now, I will discuss in details about the categories, different types of resistance welding techniques in subsequent slide. First of all, I will discuss about resistance seam welding. So, here you see resistance seam, we know that it consists of a series of overlapping spot. Here you can see this is a series of overlapping spot, which is generally used to produce an apparently continuous types of seam, we can say. So, here I am just labeling this setup, then it will be clear to you. It generally contain 2 roller types of electrode. Okay. You see these are called electrode. Here you can see these are called generally electrode. So, this is one electrode, this is another electrode. Now, generally this electrode, you see this electrode is roll over this 2 overlap workpiece. This is generally workpiece. Okay, these 2 workpieces, and this is generally you can say travel of this workpiece, you can say. So, this workpiece generally travel in between this rolled electrode. So, through this rolled electrode generally, here you see here through this generally current is passing. So, once this current is passing and this roller is rolled due to this movement of this workpiece, then what happens, whatever the point come at the close contact of this 2 electrode tip, at that location generally due to this resistance heating in this interface of 2 workpiece, there will create a spot types of joint. That is why here I have already told you it consists of a series of overlapping spot. That means, whatever the spot we are forming here, it is generally overlap with each other, that you can observe. Okay. That means, on spot types of welding or weld nugget is overlapped with each other. So, you can say this is a continuous types of welding process that we can say. So, this resistance seam welding can be operated either high frequency AC, or it can use some induction assisted types of system also. So, here a seam is produced from overlapping spot, here you can see, made at the point of contact created by 2 opposing wheel. You see these 2 opposing wheel generally carry the current, this you should keep it in mind. So, current generally here is passed between these 2 moving electrode, because this electrode is also rotating types of electrode. So, either this electrode can move, or you can move this what it is called workpiece also. So, depending upon the situation, either our electrode can be at a particular location and workpiece can move, or workpiece can be stationary and electrode can roll over the surface of this two workpiece. This you should keep it in mind. Now, here you see, in this case generally wheel or roller types of electrode are used, which I have already told you. Here pressure between them remain generally constant. In these types of welding process, whatever the number of spot is formed in between two workpiece, its range generally varying from 200 to 400. Here I have written per meter length. This you should keep it in mind. It is generally used a continuous joint require between two overlapping metal sheet. Now, what are the advantage and disadvantage of this resistance seam welding? Like it has less overlap than spot or projection types of weld. It has several parallel seam may be produced, that means parallel seam may be produced by using this resistance seam welding process. This process can generate gas tight or liquid tight joint. Now, disadvantage of this RSEW process is its initial cost generally high, that means its equipment cost is high. It is generally a little bit difficult for plate which have a thickness greater than around 3 millimeter, and which can be done only along a straight line. These types of welding generally is done along a straight line, because the motion of this electrode roll along a straight line. Okay. Now, it has some application, like it can be used for construction of tank, refrigerator, gas line tank, aircraft, container, cylindrical types of pipe. It is also used in stainless steel, aluminum and its alloy, nickel and its alloy. It has also different purpose. This resistance seam welding we can use. Now, we will discuss about resistance projection welding. This is another category of resistance welding technique. So, here these are all different types of resistance welding process. Why it is resistance welding process? Because here the heat is generated due to resistance of the material pieces. So, here resistance heating is done, that is why these are all called resistance welding process. Now, this is another categories of resistance welding process, that is called resistance projection welding. Here you see, it is a generally modification, or you can say it is a modified form of spot welding process. Why it is modified form? Because here what is required to do in work, this is one workpiece, this is one workpiece and this is another workpiece. So, in one workpiece generally a projection is required to made, here you can see. Okay. So, one of the pieces to be welded has projection produced by pressure, here you see. So, this is your one workpiece. So, in this one workpiece, I want to make different types of spot joint over the length of this workpiece. So, depending on the position of this spot, there we have to make a what it is called projection. Here you see, this is a projection we make. Projection means this is a projection. So, this projection is the important part of this resistance projection welding process, and that means beforehand we have to make a indent in one workpiece, and other workpiece, let us you see, this is one workpiece, this is another workpiece. So, other workpiece generally remain as it is. So, what happens, wherever this projection will contact with this another workpiece, at that location the current density will be high, and there generally a material will be more heated, and there generally create a spot. So, depending upon the number of this projection, the number of spot can produce at a time. So, that is why what happens, this is called resistance projection welding, because here whatever the heat is generating due to the resistance heating of two workpiece interface. Okay. Now, here you see one things you should keep it in mind. So, here you see this is called electrode, this is one electrode, this is another electrode. Now, you see this electrode has a flat workpiece, you see this is electrode, this is one electrode, this is below one is another electrode. So, these are all generally these two electrodes have a flat face, you observe that there is a flat face. So, in previous spot welding process there is a generally what happens, conical types of shape in electrode tip, but here it is a flat shape that you can observe. So, this is one electrode, this two electrode. Now, what happens here generally during heating there is apply a pressure in between this two electrode. So, during heating time once we apply the pressure, so at the projection location there generally create some spot types of weld. So, as it is formed by using some projection in one workpiece, that is why it is called resistance projection welding. So, here one thing you should keep it in mind, we are using two different thickness of plate. So, if there is a two different thickness of plate, then for that case we have to make the projection in thicker plate, this you should keep it in mind. Now, what is the advantage of this projection welding process? Projection welding process have different advantage, like more than one spot can be welded at a given time. Proper heat balance can be obtained easily here, okay, because here generally in one workpiece generally we are making this projection. So, in projection location generally proper heat balance can be automatically obtained. So, it is easy to weld certain part which cannot be welded by using resistance spot welding process, what I have told you actually, like for two different material type. Generally resistance spot welding requires some precautionary condition, that is called heat balance, but here generally that types of case this welding process is more easy, okay. Here electrode life is much larger than resistance spot welding process, because here the electrode tip is flat in nature, that what I have already told you, that is why its electrode life is much larger. Its appearance and uniformity of the weld is better than this resistance spot welding process, okay. Now, it has some disadvantage also, because first of all we have to make some projection on the one workpiece, correct. So, to make this projection it is a extra operation you can say. So, this extra operation is required in case of projection welding process. Metal generally which cannot support this projection, like hard material or hard types of metal where generally this projection making is difficult, this types of metal material piece generally very difficult to weld by using this welding process, that so cannot be welded properly. The initial cost of this equipment is comparatively higher, as there is required a press type of machine for doing this welding process, because what happens during the welding process, once this projection location is sufficiently heated, at that time we have to apply some pressure, okay. That is why what happens, there is required some equipment which should have a pressed type of machine and which generally utilize in this welding operation. Now, application of this types of welding process is in refrigerator condenser, it is used in stainless steel part, it is employed in punches where generally already projection is available already, there generally we can employ this resistance projection welding process easily. That means it is employed on punches where the projection automatically exists there. It also used in a small fastener, nut, etc. And it is also used this small fastener nut in large component by using this projection welding process. Now, flash welding, this is the another category of this resistance welding process. It is an unique types of resistance welding process here you can say, because here the faying surface is generally heated by combination of resistance and arcing. Now, here you should keep it in mind what is called faying surface. Faying surface means let these two workpiece we are going to join together, let this is one workpiece, this is another workpiece. Faying surface is the surface where generally the welding is produced. That two surface is called generally faying surface. This is one faying surface, this is another, you say faying surface, this you should keep it in mind, okay. Faying surface means the surface where the welding is produced, that we can say. Now, here you see in this types of flash welding process there is used both resistance heating as well as arc. Okay, this you should keep it in mind. How it is, that I will explain in details. Like two part to be welded here are each made an electrode of opposite polarity by hooking them up into an electric circuit. Let this is one workpiece, this is another workpiece. So, this two workpiece itself act as a electrode, because this workpiece is connected with some system. So, here I am just drawing little bit more clearly, then it will be more clear. Let this is one workpiece, this is another workpiece. So, this workpiece is connected with the power source. So, what we can do, say here one workpiece we can make fixed, another workpiece can be movable. So, you see this two workpiece connected to the two electrode. So, here workpiece itself act as a electrode, we can write here it is act as a electrode. So, you see this two workpiece act as electrode. Now, here you see, so what happens once these two workpiece come closer to each other, then at that time due to high current passes through this two electrode, at that location whatever the point will be close to each other, at that point there will develop some flashing types of effect, or there will develop some arc. So, due to this arc, that high peak point will be heated, and what happen next subsequent peak will be further heated, and gradually then overall surface of this workpiece will be generally heated. So, once it is sufficiently heated, then what happens in this two workpiece front part, generally here plastic deformation is taken place, as well as in front position some melting of material generally is taken place. Due to sufficient heating, here both paste types of material as well as molten types of material is observed due to this arcing effect. After that, a pressure is applied. Here you see this pressure is applied by using this movable workpiece, or you can say movable electrode. So, at that time generally here is occur a joining, which is generally look like, you can say in subsequent slide I will show in details. So, a joint like this types of overlapping types of joint is taken place. It is a butt types of joint you can see. So, but this butt joint is produced due to combined effect of pressure and arc, this you can observe here. So, here both resistance heating as well as some flash, that means arc is generated in this gap. What I am telling, understand, that is why it is called flash types of welding process. Okay. Now, here everything I have written in details, like as an initial gap between the two workpieces is reduced, at high point on the faying surface of each begin to cause sparking, or you can begin to cause arcing. Then it heat, then it soften and finally melt and explodes. Okay. Then shortly after this first peak, the next highest point come in proximity, and what happens, a arc is generated there, then it hit that region, it melt that region and explode, and so on. In this way generally this is a continuous process until the overall faying surface of the part to be joined are heated to a temperature sufficient to allow welding. This you should keep it in mind. Now, this flash welding process here, once the pressure is applied, at that time generally this molten material flashing out from this region you can say, and that generally flash and its frozen expelled metal is formed, and its frozen expelled metal is formed. This you should keep it in mind. So, due to this pressing time, as the material is flashing out, and what happens, as the two part is joined by plastic deformation types of material, that is why what happens, we can consider this flash welding process as a non-fusion types of welding process. What I am telling, understand. Whereas in resistance spot welding, resistance seam welding, generally these are all fusion types of welding process. What I am telling, understand, because there the material is melted over this region, and that melted material is solidified there. But here the melted material, once the pressure is applied at this time, it is generally flash out, and due to this it is frozen outside you can see. But here joining is taken place in plastic types of material region. What I am telling, understand. So, some offsetting types of effect you can say is occur here. That is why you can consider this flash welding process as a what it is called non-fusion types of resistance welding process. This is flash welding, and another welding process also considered as non-fusion types of resistance welding process, that is called offset welding. So, rest of the other 4 different categories generally considered as fusion types of resistance welding process. So, in resistance welding process you should keep it in mind, there is 2 category, one is called flash, another one is offset welding, which is generally considered as non-fusion types of welding, that I will discuss in subsequent slide. So, here I have just shown different step of this flash welding process. So, this is similar to butt welding, except that the part to be welded are joined together under the light pressure and heavy current pass through it, what I am telling, understand. Whereas in butt welding there is some different phenomena that you already know, either there is apply some filler wire or there is simply apply some arc. Due to this arc, generally there is 2 workpiece material melted and joining is taken further, but there is not apply generally pressure types of thing. But here flash welding process there is applied both pressure as well as through this electrode or 2 workpiece there is passing through some high current. Okay. So, here I am just showing here, this is generally called clamping die you can say. This clamping die, one is stationary, another one is generally this another clamping die is generally movable, which I have just shown here. Here this arrow direction represent the movable types of this electrode. Okay. Here you can observe this thing. When these 2 workpiece generally come together at this location, a arc is generated, that you can observe. So, due to this arc, this faying surface generally some portion widely heated, some portion is melted and some portion is plastically, you can say plastically deformed. This clamping die, which generally connected with workpiece, act as a electrode. This also you should keep it in mind. Now, you see, so in this location generally apply flashing voltage. This is second step which I am showing here. Generally flashing voltage is applied here, and here the parent metal start, this one workpiece parent metal start in motion. Okay. Now, here you see this is generally flash, subsequent flashing is taken place, after that generally offset and terminate the current. In this step 4, here generally offset pressure is applied and here generally current off is taken place here. So, you see a flash types of joining is taken place here. Now, I am just showing here what are the advantage, drawback of this flash welding process. This process is cheap and a faster types of process. It offer a strength which is around 100% strength, that means it offer a strength which has a factor which is up to 100%, that means its strength is close to its parent material strength. Its preparation of the weld surface is not required. Dissimilar metal with different melting temperature material also can be welded by using this flash welding process. It has some drawback like metal is lost during flashing and offsetting. Okay, due to this flashing of this or arcing of this faying surface, there can be metal lost. So, air concentricity and straightness of the work piece during welding process is often difficult to maintain. This is another important parameter, because what happens during offsetting time, there can be misalignment types of phenomena, as there is some overheating types of taken place. If there is some overheating types of phenomena is taken place, then material becomes soft enough. So, there can be chances of bending of that region. That is why here I have written concentricity and straightness of the workpiece during welding process is difficult to maintain. Here generally more chances of fire hazard. Its application, it's applied in chain, rail end, shaft axles. It is also used in welding of metal sheet, bars, rod, then what happens some rod fitting purpose also it is used. It find its application in automotive and aircraft product. It is also employed in household appliances, and refrigerator types of part. Okay. Now we will discuss about offset welding process. This is another category. It is generally more or less similar to flash welding process, but what happens, it's have some very important aspect that I will discuss in details about offset welding here. Okay. The major difference of this offset welding with flash welding is, here generally at the beginning these two workpiece generally contact each other. What I am telling, understand? So here, that is why here I have written here, the two part to be welded are in contact from the outset or beginning of the process itself. Okay. So first of all we have to let, this is the workpiece, here I am just leveling this thing. So this two workpiece, this zone is called heated zone. This two workpiece is connected to a transformer, or generally transformer types of heat source, or you can say power source, you can say transformer types of power source. This is called clamping die, clamping die. So this is another clamping die. This clamping die generally connected to the power source. With this clamping die generally the workpiece is clamped. Here you see, this is one workpiece, this is another workpiece. So this is another clamping die, clamping die. Now here you see this one clamping die, or you can say one workpiece is stationary, this is stationary, and this is generally movable. Similar of flash welding process, except at the beginning generally this two workpiece is in contact. This you should keep it in mind. So here the amount of gross plastic deformation, or you can say this offsetting that is employed to produce the weld is much higher than the flash welding process. A pressure generally applied, here you see generally this is offsetting force, you can say, or offsetting types of pressure generally applied in this movable types of clamp or movable types of workpiece. So the job are sequentially clamped and heavy current is passed through this job. Okay. The heat raises the temperature of the material to plastic state, and in this region generally fusion takes place. After that, once the material becomes soft enough and fusion takes place in this region, then sufficiently offsetting pressure is applied. Due to this offsetting pressure, this two workpiece offset in this region and a weld is formed, which is look like this. Okay. This is a, you can say this is a offset weld sample. So this is a sample of weld sample. Okay. This you can write. Now this offset welding techniques is widely used in pipes, wires, rod. Okay. This has a wide application. Now the last category of this resistance welding process is called percussion welding process. This is a very important welding process. This I will discuss in details here. It is also known as capacitor discharge welding process, because which produce weld through resistance heating by rapid release of electric energy from a storage tank. Okay. This you should keep it in mind. Here one thing you should keep it in mind, percussion meaning the striking of one body against another with some sharpness, impact or blow. So here generally sudden release of electric energy produce this weld. That is why what happens, it is, as it is a very quick and rapid types of process, that is why it is called percussion types of welding process. How it's happen, that I will discuss in details here. Okay. So it is also known as capacitor discharge types of welding process. It is a rapid welding process for similar as well as dissimilar types of material. It creates a high temperature arc that is formed from a short quick electric discharge, that you should keep it in mind. This electric discharge is occur from a capacitor. How it is, that I will explain in details. Here generally immediately following the electric discharge, pressure is applied which force the material together. So this I will discuss now in details here. Like here you can see this is called a power source. This power source is actually AC power source, you can say. transformer types of power source. Here you can see here transformer types of power source. These generally charging the capacitor, or you can say this is act as a charging unit here. What I am telling, understand? Now after that, this AC current is required to convert here by this rectifier system. This is the rectifier. Rectifier means here it's convert AC current to DC current, that is very well known to you. So rectifier means AC to DC, it's convert. After that, this current is stored in a capacitor. This current is stored in a capacitor. This you should keep it in mind. This capacitor generally store this DC current, and what happens, this capacitor also make the DC current smooth. That means this capacitor is also act as a smoother of DC current. This you should keep it in mind. Okay. Here also more or less similar things like in flash bar and offset welding techniques. Here is also used what it is called a stationary workpiece and a movable workpiece. This you should keep it in mind. And here is used a spring system. Here you can see is used a spring system. It generally press this movable workpiece and it make contact with this stationary workpiece, and at that time generally arc is generated. Due to this arc, what happens, the material becomes soft enough and welding is produced. For that reason, for this spring to create pressure in another workpiece, there is used a trigger. Just I am showing here a complete setup of percussion types of welding process. Okay. Now here you see what are the things required to do. Here we have to store the power in a capacitor. What I mean, that is called electrostatic capacitor. This also you should keep it in mind. Electrostatic capacitor means here the electric energy you can say is stored here. So once we just it has a, you see double types of switch, you can see two-way switch are there. So once it connected to upper connector, then what happens, it will start charging. Once it connected to lower charger, then it release this charge electrostatic energy, so that what happens, due to this sudden electrostatic energy from this capacitor, what happens, there is occurred a sudden types of arc and sudden types of what it is called welding phenomena. That is why this is called percussion welding process. This you should keep it in mind. Okay. What happens, once we generally apply the pressure on trigger, that means on this, once we trigger this what it is called movable workpiece, then what happens, it generally move toward a stationary workpiece. Once the distance between these two workpiece is around 1.5 to 1.6 millimeter, at that time generally a high intensity arc is generated in this region. Okay. So due to this arc, these two workpiece melting is taken place, and after that further this contact of these two workpiece is taken place and welding is done. Okay. So as it is done very rapidly due to this discharge of electrical energy from this capacitor, that is why this is called percussion types of welding process. This you should keep it in mind. Okay. Now what is the advantage, disadvantage and application of this welding process, that I am just showing here. You see it is a generally very rapid welding process. Here generally time is required only around 0.1 second. More arc temperature than flash bar welding process, because here the energy is released from a capacitor which generally stores the energy. So it generally suddenly release the energy, and that is why what happens, due to this high release of energy, here generally more arc temperature is generated than flash bar welding process. No or very less offsetting here. Okay, because here localized heating is taken place, and in this percussion welding process another advantage is its heat affected zone is very less, shallow heat affected zone is produced. It has some disadvantage also, because this percussion welding mainly used in bar welding purpose. It is very highly expensive types of equipment. Its application is in fine wire leads to filament in lamp. That means in filament which is used in bulb, electric bulb, generally this with this fine wire to filament bulb also can be joined by using this percussion types of welding process. Okay. It is used in telephone industry a lot. It is also used in different types of similar and dissimilar types of metal, like what happens, it can used to join zinc to steel, cast iron to steel, copper to nichrome, copper wire to stainless steel, copper to aluminum. It is also can use thorium to zinc alloy types of material. So, it has different types of application. So, this all about today's lecture. So, these are the references which I followed for making this lecture. Thank you.